I'm going to go through a past paper question from 2016 May. It's time zone 2, and this is a paper 1 question. It's question 10 from that paper. So quite a long question, and it mainly focuses on calculus. So I'm going to take each part of the question. So we have A, I, B, and then C. So quite a lot of marks in each one as well. So just to have a read through the question first, you have a diagram showing this function, and the function is defined from -1 to a, and a is a value greater than 1. So these are all technicalities. Line L is tangent to the origin. So the main concern, L links with this function through the point 0, 0. And the point P, which has value A and B, lies on this specific line. QA0 lies on the graph of F, so it's here. And R is so it's defined here. So Q is here, and R is the region enclosed by the function and the x-axis. So we'll be using all of this information as you expect in later questions. And at the bottom here it says, let AR be the area of the region R. So all this information will be used later. So for part A, it tells you, given that the derivative of this function is such, find the equation for L. So to find the equation, L, remember, is a linear line, which means it will have the form of y equals mx plus c, where m is the gradient and c is the y-intercept. And so you'll have to first be able to find the gradients and then find the y-intercept. It's obvious that the line L intersects at 0, so the c value is actually 0. But I'm going to get to that in a bit. So the gradient, though, can always be found using the derivative. So always remember that your gradient links with the derivative. Because what the derivative essentially is, it's a gradient function. It's the function of the gradient. So if I want a gradient at 2, I'm going to substitute at 2, and I'll know the gradient at the tangent at point 2. So this is a line at point 0. So L is concerned with the coordinate 0, 0. So the x value is 0 in this case. This is what matters right now. So if I want to know the gradient of L, then I need to find the gradient at point 0. This is always the link you're going to have to make. If I give you a function, say 3x squared, and I want the gradient at 2, what I mean is, if this is my function and this is the value of 2, then I can draw a tangent. And I want the gradient of this tangent that only touches the point 2. And in order to find it, you first derive, and then you substitute your value that you need. And so your gradient of the gradient of this line will be 12. So that's the concept, and I do explain it in another video in more detail. So we're concerned with 0 right now, so I'm going to substitute 0 in there. So be careful, some students do substitute 0 for a, but this is not what we're substituting. We're substituting x. So we get 0 here, square root of a squared minus 0 squared, and that will simply give you 2a squared over a, because you'll end up with square root of a squared, and if you square root a square number, you just end up with the number itself, and this is just equal to 2a. So this is the gradient, this is m. And so you have the equation of y equals to 2a. Now, here's a bit of an uncertainty with how I'm going to answer this question, because I would usually leave it as 2ax. The gradient is 2a, and so you need to have it in the form mx. So m is 2a, and then you need to attach the x in there. So this is the form. Now the y-intercept is obviously 0. So my intuition would tell me to put 0. However, the marking scheme has a very confusing comment, and I haven't found anywhere where it explains otherwise. So I'm just going to explain what the marking scheme has. And it says to penalize any attempts or anything written as L equals to 2AX. So you're not allowed to put this, which I'm not sure why, because it's obvious that the y-intercept is 0. So let's just follow through what the marking scheme also has. So if you ever want to find the y-intercept, let's say it's not 0, then what you're going to do is you're going to substitute a value of y and x that you know lies on the line. So we know that P lies on this line. If P lies on the line, it means that P fits this. It means that P fits the equation of the line. And so if P fits inside the line. So if P is A, B, it means your x value is A and your y value is B. So B to A plus C, and this will give you, this will give you 2A squared plus C. And so actually your C value is B minus 2A squared. And so your final form would be y equals to 2ax, so this was our m, plus c, so plus b minus 2a squared. Again, not something I'm convinced about, but the marking scheme has this anyways, and it might be useful in case you have a line that doesn't pass through the origin. So for part II, it says hence or otherwise find an expression for b in terms of a. So you might have found it already. Well, we could use the fact that we know c is equal to b minus 2a. And we know actually that the y-intercept is 0. It's very obvious that it is 0. And the question recognizes that it is 0 actually. So it is equal to 2a. And so if I rearrange to make b the subject, I end up with b equals to 2a squared. Students do get confused with this sentence. When I say I want an expression for b in terms of a, an expression for b means I want b to be the subject. So I want b to be the subject and the a to be my variable. So I can't have plus x plus 2y. I can't. This will be an expression of b in terms of a, x, and y. If I just want it in terms of a, then it has to be the only unknown in the equation has to be a. But you have to make b the subject. So just be used to this sentence. Now this is one method to do it. Another method is to recognize that your gradient is 2a. And the way you find the gradient is by doing y2 minus y1. This is the typical way for linear equations. And then x2 minus x1. Which means you need two coordinates, where we actually have two coordinates. One is AB and the other is the origin. They both lie on the line L. So you have A, B, and you have 0, 0. So if I substitute these in here, I get B minus 0 over A minus 0 is equal to 2A. And so I get B over A is equal to 2A. And if I cross multiply, I get B is equal to 2A squared. So that's another method. So you've written an expression in terms of B. And this will come useful later on, so keep it in mind. Now it gets into a bit of integration. So show that the area is 2 over 3a cubed. So I need a bit of space here. So we need to show that this area is 2 over 3a cubed. It seems quite far to get from this function to here. But it's not too bad. It's just knowing the techniques. So if I define... So in order to show the area, in case you didn't know, to find the area of any function, it also means you're integrating. So just as we said, the gradient always links with the derivative, then the area always links with the integration. So we need to integrate f of x, and it has to come from 0 up to a. So 0 up to a. So this is how far you're integrating this function. And the reason we take the x coordinates is because you're differentiating in terms of, you're integrating in terms of x. So basically what you're trying to integrate is 2x. So your original function, 2x square root of a squared minus x squared dx. Quite a long one, seems complicated. Now here's the trick. You obviously with square roots and stuff, you're not expected to know how to differentiate these by sites. We do expect you to use different techniques for integration, especially if this has 6 marks on it. So for this part, if you notice, if you differentiate this x squared, you're going to get a 2x, which matches with the 2x here. So there's a bit of cancellation that you want to happen. You want to get rid of as many variables as you can. So in this case, you will immediately go for substitution. So you should have a first approach when it comes to integration. One of them, can you do it directly? Second, can you separate the functions? Third, can you actually use substitution? If you're doing HL, you could do partial integration as well. So for this, I'm just going to use a substitution. So I'm going to substitute this complicated things. Anything under square root, you want to keep it simple because it's much easier to integrate this than integrate this whole mess. So what I'm going to do is say u is equal to a squared minus x squared. So this is me just following the substitution method. So we're taking a detour here. And so du by dx, which is me differentiating this cancels out. It's a 0 because it's a constant. Remember, a is just a number. And this will be negative 2x. And so if I rearrange this, because not only are you meant to substitute this, you're also meant to substitute the dx. And if I make dx the subject by cross-multiplying, so I end up with dx is equal to du over negative 2x. So now I have an expression in terms of dx, an expression in terms of u. I can make my substitution here. So you have 0, a, 2x, and now instead of whatever was under the square root, you're going to put u. And instead of dx, you have du over negative 2x. And this is what you want. This is what you always want with substitution. Either you make it simple, or you also cancel out some extra terms. So this will cancel out with here, and you don't forget the negative. So I'm just going to put the negative out. You're allowed to do that, or you can put it inside. It's up to you. du. So I can differentiate this. Let me just rewrite it as a fraction. Negative a half du. And differentiating this, you always add a power to here. So you have u to the power of 3 over 2, and then you take the reciprocal of the power, so 2 over 3. Because if I undo this, if I actually differentiate this, I should end up back here. And again, don't forget about the negative. And this should be evaluated from 0 to a. But then now we've differentiated, oh nice, let's bring back the original expression. So you have negative 2 over 3 square root, oops, not the square root, negative 2 over 3 a squared minus x squared to the power of 3 over 2. All of this evaluated from a to 0. So let's evaluate this. So I'm going to substitute a in first. So I have negative 2 over 3 a squared minus a squared to the power of 3 over 2. So this is the first substitution, minus negative 2 over 3 a squared minus 0 squared and 3 over 2. So this will end up being a 0. 0 times all of this will be a 0, so you have a 0 here. And then you have a minus minus, so that's a plus. So just these two. And you end up with a 2 over 3 a squared to the power of 3 over 2. And what you're going to do is just use the rules of indices, which is if you have something to the power and it's raised to another power outside the bracket, then you multiply the powers. So you have 2 over 3a 2 times 3 over 2. And that will simply be because this is over 1. You can cancel these two out, or you can multiply. You're going to get 6 over 2, which is just 3. So you end up with this. And this is what they needed, 2 over 3 and a to the power of 3. Now, for the last part, let's AT be the area of the triangle OPQ. So this is OPQ. Given that AT is K times AR, find the value of K. So basically what they're telling you is the area of this triangle is a multiple of this area. So if I take my AR, which I know what it is, and I multiply it by a specific amount, it's going to give me the area of this triangle. So if you notice, this triangle is a right angle triangle. It has a base length of A, because I'm going from 0 to A, and it has a perpendicular height, again going from 0 up to B. So B is your Y value, and so the area is half times AB. And we know the area of AR is 2 over 3 A cubed. And I know that this can be found by multiplying this by a specific amount. So we know that AT is equal to KAR, and we're meant to find K. So half AB is equal to 2 over 3 A cubed. But here's the thing, times K. So we remember when I said the B will be useful. So it would be nice to have everything in terms of B here, because they'll cancel out. Now you can go through with it, but you'll end up with something in B. And it's much better to just find the value of K, because they did say, the clue here is that they said find the value of K. They didn't say find an expression of K in terms of A, which means you expect a lot of things to cancel out. Now we know that B is equal to 2A squared. So we're going to use this information. Now either you spot this from the beginning or you spot it later, it's fine. So I'm going to substitute, instead of B, I'm going to put 2A squared. And I have my K times 2 over 3A cubed. So this will simplify to A cubed is equal to K 2 over 3A cubed. So we cancel this 2 out, and the A cubes will cancel. If I divide by A cube on both sides, they both cancel out, so I end up with a 1, not a 0. Please be careful here. And 2 over 3. And obviously it makes much more sense to write 2 over 3K. Which means that if I just reciprocate this to the other side, so I get K is equal to 3 over 2. You can think of this in as many ways as possible. You can cross multiply this. You can divide by 2 on both sides, so you end up with this, and then multiply by 3 on both sides, so you end up with this. However you want to test it out. So K is equal to 3 over 2. If you didn't do this canceling out, you would have ended up with a 3 over 4 B over A squared. And so it would have been find an expression of K in terms of B and A, not the value of K. So be careful with the wording. It should give you a hint. But you would have gotten marks anyways for how far you've gone. So this is the end of the question. So quite a long one, but interesting as well. So I've seen this type of question used as well a couple of times. So do learn from these techniques, mainly the substitution method, the finding a value of as areas are multiples of each other, and things like finding expressions in terms of, and definitely finding an equations or finding a gradient of a tangent. So these are the main key points you need to learn from this question to apply in many other questions.